I thought I would run through the problems from the practice here, so if you have any questions, maybe this would help. This first one says, draw the appropriate construction, angle bisector, perpendicular bisector, altitude, or median that is used to find the incenter of the triangle. I don't want you to use a compass, I just want you to kind of eyeball it to do that. But you ought to know like the attributes, what makes the incenter. So a quick reminder, to get the incenter, you do the angle bisectors. So I'm just going to make an approximate of what the angle bisector would be like on that. So that looks like it's pretty close to bisecting the angle. Do the same thing over here. That looks like it's pretty close. And okay, so we know that, right? Angle bisector cuts that in half. That's an angle bisector. That's an angle bisector. Where those three intersect is the incenter. Its special attributes. Okay, number one is that point is the same distance. Measure the distance from the sides of the triangle. So that distance and that distance and that distance is all the same. So same distance from all the sides of the triangle. That's where all the angle bisectors meet. If you want to, right, the incenter, you can take a circle that's inscribed inside of the circle, and draw it, and it will be perfectly inscribed inside of the triangle. If you start from the incenter, that wasn't the best drawing. And so just know incenter, angle bisectors, that's where they all cross at, and it's the equal distance from all the sides of the triangle, and you can draw that inscribed circle inside of it. On your practice, I don't care that you do both examples. Like just do one, make sure you know how to do it. Okay, so this one is the orthocenter. So orthocenter, if you remember, is all of. The orthocenter is all the altitudes of a triangle. So this one's a little bit tricky. This one's an obtuse triangle. So if I want to draw the altitude, I've got to extend out that side. So I'm going to extend that out. And then I'm going to draw my line. It goes from the vertex perpendicular to the opposite side. Again, we're just eyeballing this. So something like that, it has to be perpendicular. Pick another angle and do the same thing. So let's do this one over here. That means I have to extend out this side. Okay. And draw a line that is perpendicular to it. Something like that. That has to be perpendicular. So this point right there is going to be the orthocenter. We could draw the third one, right? This is probably the easiest one to draw. We're going to go from the vertex perpendicular to the opposite side. I'm going to have to fix that just a little bit. But again, you're not going to have to construct any of these perfectly. This just needs to be an approximate. So this point out here is the orthocenter. The orthocenter can be inside, it can be outside the triangle, it can be inside the triangle. It can actually be on the vertex of the right angle if it's the right triangle. There's not really other than knowing that it's where the altitudes cross, there's no really other special properties of orthocenters that you have to know. Hey, going back to the incenter really quick, one other thing, that incenter is always inside the triangle. Should be easy to think about. Incenter is inside the triangle. Okay, the next one we're on now is we're going to find the centroid. So for the centroid, you draw all the medians. The median is, you find the midpoint of one side, and I'm just going to guesstimate here. I'm going to say that's the midpoint, so it cuts that in half. And all we do is draw go from the vertex to the midpoint of the opposite side. So let's say the midpoint of that one is right there, it's cut in half. Okay, and we're going to go from the vertex to the midpoint of the opposite side. We'll do one more. We'll draw all three of them. And the point where they all cross, at that point is the centroid. The centroid is always inside the triangle. Its special properties. Remember, is that it divides these segments. So this segment right here, that, and that, into those third pieces. The red is 2/3 of the entire thing. The blue is 1/3 of the entire thing. So that's what you have to know about the centroid. Something you don't have to know, but it's kind of interesting, is the centroid is the center of gravity for the triangle, which means if you find that point, you put your finger underneath and you can bounce that triangle perfectly, which is kind of cool. Okay, the last one is the circumcenter. If you're going to find the circumcenter of the triangle, we're going to do the perpendicular bisectors. So I got to take this side and find the midpoint. Again, I'm going to guesstimate midpoint about right there. Okay, and now we just draw the perpendicular bisector. I'm going to draw the line segment. We want it to be perpendicular to that side. And I'm going to adjust that just a little bit. That looks pretty close. Okay, let's guesstimate the midpoint of another side. So let's say right there. And we'll make a little tick mark showing that it's the midpoint. And again, we're going to do the perpendicular bisector. So just to make sure this has to be perpendicular, right? And that looks like the cross right there, that's where it's going to be. We can do the third side too. If we came up here and guesstimated the midpoint and drew that line. And where all those cross then is the circumcenter. Now on this one, the circumcenter is outside of the triangle. The circumcenter can also be inside. It can be inside, outside, or it can be on the triangle if it's the right triangle. You're not going to have to find any of these centers. I'm just going to give you, you can have 8 questions on these. One is, I'll give you a picture. You have to tell me whether it's the in-center, circumcenter, centroid, or orthocenter. And then I'll also ask you a question, like a fill in the blank, about the attributes. For example, I would say, oh, we never talked about this, but the attributes for a circumcenter is at that point is the same distance from the vertices of the triangle. So if I measure that distance, and that distance, and that distance, it's all the same. Also, you can take whoops, was a bad circle. But if you take that as the center of your circle, you can make a circle that's on the outside of the triangle. So right in the center, you can draw that circle inside of it. Circumcenter, you can draw that circle on the outside. So again, you'll have to identify all 4 of these, and then you'll have to know their attributes. In-center is equal distance from the sides of the triangle. Circumcenter is equal distance from the vertices of the triangle. The centroid forms those ratios at 2/3 and 1/3, and the orthocenter doesn't really have anything that's terribly special about it. Okay, moving past those, let's go through these really quick. It says state the number of state whether if the 3 numbers can be the measures of the sides of the triangle. And this is really simple. All I do is add the 2 smaller sides together, and it has to be greater than the 3rd side, right? 12 is greater than 10. This would be a yes. Add 8 and 3 together with its shorter sides. The question is that greater than 11? Well, no, it's equal to 11, so this would be a no. This is almost the same, but this one we're trying to find what could be the range of possible measures from the 3rd side. So all I do is take a 10 and the 7 to find the shorter one. I subtract them. So I know my side can't be bigger, it has to be bigger than 3. And it has to be smaller than when you add those together. So you subtract them to find the lower range. Oops, it's supposed to be an inch, I think. And you have to add them to find the upper range. So I know that, scribble that out. I know that my range of possible values for the 3rd side is between 3 and 17. It has to be bigger than 3, has to be smaller than 17. This is right, if I compare the angles, I can compare the sides. Let's do this one over here. So if I take 88 plus 6, I need to figure out what that angle F is. So if I take 88 plus 68, that's 156. Subtract that from 180. So 180 minus 156 would be what, 24 degrees? Hopefully I did that right. Okay, now compare the sides. So it says to list it from shortest to longest. Well, the side opposite F is GH. So GH has to be the shortest side. The next smallest angle is 68. It's opposite GF. That's to be the next shortest side. And the longest side, the one biggest angle is 88, so the longest side has to be HF. Pretty simple. 15 and 16 are almost the same. In this case, we're comparing the angles. So if I want to list my angles from smallest to largest, the smallest side is ML. So angle N has to be the smallest angle. The next one is 22, it's opposite angle L. And then the longest side is 24, so angle M has to be the biggest angle. So you compare the sides with the angles or compare the angles with the sides. It goes either way. Okay, medians. So it says M, N, and P are the midpoints of the sides. So we know this is a midpoint. That makes that a median right there. Okay, that's a midpoint. That's a midpoint. Okay, the two things we talked about this is the mid-segment is parallel to the third side. So MN, oops, that was the wrong one. Sorry, let's do that again. MN is this one right here. It would be parallel to the third side, which is this one over here. So it would be parallel to SQ. The other thing we talked about is that it has to be half of that third side. So if the third side is 20, this mid-segment has to be half of that, so it has to be 10. We can make that a little bit tougher by making them equations. I want you to notice this is the mid-segment, right? That's the midpoint, those two are equal. That's the midpoint, those two are equal. So this is the mid-segment, so it has to be half of that third side. That means I can take the mid-segment and times it by 2. 2 times x plus 18, and that would have to equal the third side. Then I would solve that equation from there to find it. Okay, we talked about perpendicular bisectors and angle bisectors. So if you look at this first one, this segment looks like a perpendicular bisector. We know that it's perpendicular. We don't know if it bisects it, but our theorem was if you take a point on that line, if it's equal distant from both endpoints, like 7.4 and 7.4, that means it is a perpendicular bisector. That means those segments are equal. So if that one's 5.1, this one has to be 5.1. It actually asks you to find PQ, which is the whole thing. So that'd be what, 10.2? You can also go the opposite way, right? If I know that it's bisects that and it's perpendicular, then I know those two have to be equal also. The other thing we talked about was with angle bisectors. We know this is the angle bisector, right? It's smart, they're both 33 degrees. That means that any point on my angle bisector has to be the same distance from there and from there. So those two have to be equal. So that's 46, and JM also has to be 46 also. What's a median? Draw one median of the triangle. Okay, just remember the median goes from the vertex to the midpoint of the opposite side. So let's say that's the midpoint. Okay, that'd be my median right there. I could draw them all. Like here's my median, there's my midpoint of that side. And then, we kind of already talked about this, right? If I draw all the medians, that point where they cross at is the centroid, and it forms those ratios, right? This segment, this small segment, is 1/3 of the entire thing. This segment right here is 2/3 of the entire thing. Let's see, this is where we're comparing two triangles. So we want to say is QRP, this angle, is it greater than, less than, or equal to PSRP, which is that angle? Well, remember, we can compare those two angles. If I have two congruent sides, we know those two are congruent, and they share this side, those are congruent, then I can compare those two angles by looking at these two sides. So if you look at that, 5.4, let's see, QRP is that angle. It's opposite the 5.1. It's smaller. 5.1 is smaller than 5.4, so that angle has to be smaller than this angle over here. So we would say it is less than. Here's another example where the triangles aren't next to each other. This is really similar, right? For this theorem to work, you have to have that side congruent to that side, and those two sides congruent. Okay, so we've got two congruent sides. I can compare the third side by comparing the angles. Okay, this angle is bigger. That means this side has to be bigger than this angle. So that means that XZ has to be greater than AC. So I'm going to say XZ has to be greater than AC. So you can compare the third side using the angles, or compare the angles using the third side, as long as you have two sets of congruent sides. Okay, last thing. Okay, indirect proof. I decided not to make you do a proof. I was going to, but then it's just hard to do with, with our testing format. If we were here at school, we would definitely do this. So instead, I'm just going to have you write the first step. This is when you assume the opposite. So suppose you want to write an indirect proof for each statement. As the first step of the proof, what would you assume? So A says triangle BOX is not a cube. So if you're going to write an indirect proof, you start out by saying assume that, and it has to be the opposite of what's right there. So you say triangle BOX is a cube. Okay, and that's all I'm going to ask you to do on the test. Now, if we were writing the proof, you would go on, you would reason logically from there until you came up with a contradiction. And once you show that triangle BOX could not be a cube, that means you prove that A is true. Okay, B says at least one pair of shoes you brought costs more than $25. So the first step is going to say, assume that all pairs cost less than $25. That'd be my negation or my assumption of the opposite. Okay, make sure you ask me questions. I'll have that Google Meet Friday morning. I'll post more information on that. So if you got questions, you can call into that and ask me. But make sure you're prepared for the test and you're ready to go.